Today we will learn some terminology which is used in the investigations in a pharmaceutical fields. There are a number of incidences happens in a laboratory. That's called as a laboratory incidence report. Second one is called as OOT, that is out of trend results, and third one is called out of specification, that is OOS. So the basic theory of all investigation are kept in a similar way. You have to perform a gamba walk, or you can say as a preliminary investigation. What happens in a preliminary investigation? When an OS or any incidents or OT observed, the section head or the supervisor go to the shop floor, and then he perform the investigation regarding to the documentation and the accessories, or you can say glasswares, diluent, then instruments, what the parameters used in instrumentations, that should be verified by the section head, or you can say supervisor. That activity is also called as a gamba walk. So the gamba walk is terminology which is a Japanese word, which means a shop floor. Shop floor means the place where the activity was performed. In case of manufacturing, so the shop floor will be the manufacturing area. In case of quality control, the shop floor will be the bench top where the analysis was happened, and the instrument in which the analysis was happened. So after getting an incidence or OS or OT, the gamba walk is done. That's called preliminary investigation was done. If anything identified which is not done as per STP, that is called that error is called as obvious error. Obvious error मतलब कि एनालिस्ट ने कुछ एक्टिविटी गलत की है जो STP के अंदर मेंशन नहीं है, and that is directly seen by the supervisor, or you can say laboratory planner. After identifying that, you had to give corrective action and preventive action of that obvious error, and then you have to close the investigation. If you did not get any obvious error during your gamba walk, or you can say a preliminary investigation, then you have to go for a hypothesis. Hypothesis is the word which is which can be defined as a predetermined condition or predetermined things which can impact your results and which can result your non-confirmatory results. That could be a OS, OT, or it could be an incidence. So in a hypothesis, generally 4 sections are done. First one is a injection of same vial to identify the instrument error, then injection of refilled solution to identify any error during filling of your solution in SPLC vials. Third one is done for a dilution, that's a redilution, called as the dilution activity to identify the dilution error. And third one is done for resonication, so to identify resonication or sonication error. So after getting the results of all these 4, we can come to some conclusion that either my analyst has done some error during while filling, that could be a mixing of solution, or that could be a filtration error. Then second one could be a instrument error. If my instrument is not giving the similar result which was given initially, means my initial result was OS or OT, and the same solution is giving now passing result, which indicates that there could be some error during the instrument working. So that indicates instrument malfunctioning. If my redilution is coming to target value, then it indicates that there is some error during your dilution. And if my resonication result is coming near to target value, means there was some error during sonication which resulted into your non-confirmatory results. After getting a hypothesis result, we can conclude that either I have get the root cause of this my non-confirmatory result. Then the again same what activity we have done after identification of the obvious error, that could be done, means you have to give assignable cause, root cause, and CAPA. Then you have to go invalidation for that investigation. If you didn't get anything during your hypothesis, then you have to go for some extended laboratory hypothesis, means you can say it could be a simulation. So the simulation is the condition where you recreate the similar condition which is suspected that may affect your results, then that condition to be recreated. That's called a simulation, or you can say extended laboratory hypothesis. In extended laboratory hypothesis, you have to recreate the same conditions which you have suspected. That could be that there might be some solution, that some sonication error, some dilution error, some filtration error. But the base of this extended laboratory hypothesis, or you can say simulation, that is generates from the review of your background data. So the background data can be understood in a manner of the other test results. If my OS is observed in a assay test, then I have to relook my content uniformity test result, then I have to see the dissolution result of that under investigation batch, and yes, of course, the previous stage results, that is a lubricated blend results, that could be a assay and blend uniformity test of that same batch. If my all results means my all other test results are near to 100% and my this OS result is coming around 110 or 90%, then yes, there could be some analytical error which resulted into OS results, or you can say non-confirmatory results. So then the simulation has to be done and you have to identify the root cause. If my all results are still similar to the OS results, means the dissolution criteria has a very wide range, means that is not less than 80, means if my result is coming to 85, again my results are passing, but it is not near to the target value. Similarly in content uniformity, if my all results are coming nearly to each other, so again the AV value, means the acceptance criteria of the content uniformity, will not fail. So I cannot compare that content uniformity result with my failing assay results. In that case, we have to go for a phase 2 investigation. In a phase 2 investigation, we have to go through manufacturing as well as extended laboratory investigation. In phase 2 investigation, the quality control department perform a multiple sample analysis, means the analysis on multiple samples. If my original sample is not available, then we have to go by a resampling by giving a scientific justification. And in phase 2 investigation, after getting all results are complying to phase 1, then again we have to rethink on initial results. And then again, if it is observed that my initial results are still valid and we don't have a root cause, then the OS stands valid. The same things should be also reflected in a manufacturing investigation also. If there is some identification of the assignable cause, the manufacturer or the manufacturing team should give the root cause, proper justification of that cause, and after giving assignable and assignable cause, corrective action and preventive action, we have to close the investigation. There is a lot of confusion arises when we use the terminology corrective action and preventive action. So the corrective action is the terminology which is used to eliminate the non-confirmatory condition, that is undesirable condition, and the preventive action is the condition or the action which is used to stop the occurrence of the non-confirmatory condition. इस चीज़ को हम एक तरीके से जनरल तरीके से समझ सकते हैं. इफ़ सपोज मेरा आज मोबाइल का स्क्रीन टूट गया, सो व्हाट आई हैव टू डू, आई हैव टू फिक्स माई स्क्रीन ऑफ द मोबाइल, दैट विल बी करेक्शन, एंड देन आई विल पुट स्क्रीन गार्ड ऑन माई मोबाइल स्क्रीन. सो दैट विल बी करेक्टिव एक्शन कि मेरा मोबाइल का स्क्रीन आगे फिर से ना टूटे. सो व्हाट विल बी द प्रिवेंटिव एक्शन? सो द प्रिवेंटिव एक्शन विल बी रिस्क बेस्ड स्टडी which identified that other harms of the same condition, means what are the other possible errors which can cause the breakage of your mobile. So what I will do, I will add a cover on my mobile phone, so whenever the physical shock will be given to the mobile, my mobile screen or any part of mobile will not break. तो ये था एक कॉमन टर्मिनोलॉजी सीखने के लिए कि करेक्टिव और प्रिवेंटिव एक्शन में फ़र्क क्या होता है. अगर हम इसको एक मशीन के तौर पे अगर लें, लाइक जैसे फार्मास्यूटिकल कंपनी, If there is an OS observed due to breakdown of any parts of your machine, so the correction will be the replacement of that part. Then the corrective action will be how I can eliminate the condition of my instrument error. Means I can introduce a checklist for the maintenance of that part of the machine. That will be my corrective action. And the preventive action will be I will evaluate the other parts of the machine also, which can cause a similar error, which may result in a non-conformity results. So my preventive action will be I will check the other parts. If there is a risk ki yes, if due to failure of this part the similar result or similar reoccurrence may occur, then I have to give such a preventive action to avoid that conformity. Thank you.